Speaker this morning is Julian Cribb. Now, Julian's been commentating on the beef industry and where it's been for a long time. He's just written a book recently, and he's going to outline to us today where he sees the future of our industry. Please welcome Julian Cribb.
Thank you very much indeed, Mr. Chairman. A privilege, ladies and gentlemen, to be asked to speak to you today. I'm suffering from an attack of deja vu. First time I came to Rocky, I was the editor of the National Farmer. It was 1976 and it was the height of another beef cattle crisis. I take this magnificent venue as the evidence that the industry rode out that crisis, and it's going to ride out this one too. The reasons, how it's going to ride it out, I'm going to outline in the big picture for you. I'm not going to talk about the industry in Australia, I'm going to talk about what's happening to food worldwide and how those trends are going to affect all of us. Now, most of you are probably familiar with the UN forecast there's going to be 9.2 billion people in the world of 2050. However, history is not going to stop there. There's going to be 10 billion people by 2060 and maybe 11 by 2070. So population is going to keep on going. Equally, the world economy isn't going to come to a stop. China, India, and other advanced economies will continue to demand more protein food. So global food demand is going to double over the coming half century as we add another 4 billion people. That means we're going to eat roughly 600 quadrillion calories every day. That's the equivalent of feeding 14 billion people at today's level of nutrition. So my first point is that the central issue in the human destiny in the coming half century is not climate change or the global financial crisis. It is whether humanity can achieve and sustain such a food harvest. My second point is that food production today faces critical constraints. Not just one or two, but a whole constellation of them, playing into one another, and serious ones. This is the big difference from the 1970s. Then we could fix the problem with a bit of technology and skills. Today, the world faces looming scarcities of just about everything you need to produce quality food. Water, land, nutrients, oil, technology, skills, fish, and stable climates. And each one of these feeds into all the others, compounding them. So this is not a simple problem, one that can be solved by techno-fixes or government policy changes. It is what is known as a wicked problem. By 2050, there's going to be 7 or 8 billion inhabitants of the world's cities, just living in those urban areas. And they're going to use 2,800 cubic kilometres of fresh water. That's more than the whole of irrigation worldwide uses today. Now, some of them may use a bit of desalination, but most of them, it will be cheaper and easier to grab the farmer's water. And then there is the slice of the farmer's water that climate change is already stealing, whether it's rainfall over the Great Grain Bowls, evaporation from storages, shrinking rivers, or the loss of meltwater from mountain glaciers. Yes, the Himalayan glaciers are disappearing. The only debate is how fast. And the North China Plain is running out of water. Now, those two regions alone feed 1.7 billion human beings now, and they have got to feed twice that number in 2050. Worldwide, groundwater tables and rivers are dropping as they are pumped dry. I mean, that's Lake Chad at the bottom left there. It's gone from full to 90% empty in the space of about 25 years. It supports 30 million people. International Water Management Institute Director Colin Chartres, who's an Aussie, says current estimates indicate we will not have enough water to feed ourselves in 25 years' time. Then there's land. Today, about a quarter of the world's land is affected by serious degradation. That's up from 15% 2 decades ago. The most recent FAO study indicates the world is losing about 1% of its productive land every year to erosion, urban sprawl, mining, recreation, toxic pollution, and rising sea levels. Now, if we've already lost 24%, and we lose 1% a year from here on in, you can work out for yourself how much land we are going to have left in 2050 on which to double food production. Any way you look at it, farmland is shrinking in relation to the number of consumers. Between 1990 and 2005, world demand for food grew 15 times faster than the area of land producing it. By 2050, the total area of farmland buried under cities will exceed the total land mass of China. The total area of land diverted to recreation and other non-food activities could rival that of the United States. This is nearly all productive land in river valleys and on coastal plains. The world needs to understand that the word development has a new meaning: the elimination of food potential. We need to start passing laws to stop it. Now, many of these big cities will have 20, 30 and even 40 million inhabitants. So you can imagine a city with twice the population of Australia. Yet they will have almost no capacity to feed themselves. They will be in huge jeopardy from any natural or man-made disruption to their food supplies caused by a shortage of transport or energy or a war or anything that comes along. They will be death traps. The next issue is nutrients. We're losing nutrients at every link in the chain, from farm to fork. On farm, up to half the nutrients we apply can be lost in soil, water and the environment. The resources of mineral nutrients, the stuff we're mining to make our fertilisers, are starting to fail. When Canadian Patrick Derry applied Hubbard's peak theorem to phosphorus, he found, to his dismay, the world had passed peak phosphorus in 1989. According to the International Energy Agency, we're due to pass peak oil and gas this decade. And together these spell scarcity and soaring prices of the primary nutrients, nitrogen, phosphorus and potassium, that sustain all advanced food-producing systems. At the other end of this equation, we're losing a lot of these nutrients into our lakes, seas and oceans in ways that prevent our getting more food from them. We're destabilising the global nutrient cycle. And if we double food production and we double the amount of nutrients flowing into it, we're going to destabilise it even more. Then we've got the issue of waste. Now that, ladies and gentlemen, that lovely food there is what the average Western family throws away every month. We throw away, or we lose, from a third to a half of all the food we produce. The Stockholm Institute calculates that 2,600 out of every 4,600 calories harvested are wasted. Put another way, half the achievements of the world's food producers are going straight to landfill. While 1 billion starve, we waste food enough to feed 3 billion. Our grandparents would say we were idiots, and they'd be right. Peak oil has already happened in the US, in Australia, Britain, and in 49 of the world's 65 oil-producing regions. Yet 51 million new cars hit the road every year. Oil is essential to our food-producing systems. They can't function without it. Now, the average citizen of a developed country like Australia consumes the distillate from 66 barrels of oil in the form of food. That is how dependent we are, every one of us. So one of the most critical issues is, where is the energy going to come from to power the pumps, the tractors, the four-wheel drives, and the trucks, the trains and ships that move our food? It cannot come from the farm. If you do that, you will cut the world harvest by 10%. If you add the transport component, you'd cut the world harvest by 30% at a time when we need to double it. Now, optimistically, we've got until about 2030 to solve this problem and convert most of our food-producing systems to another energy source. It might be algal biodiesel, or hydrogen, or solar electric. But I'm not seeing any sense of urgency from governments anywhere at the moment.